Hello, everybody, and welcome to Rocket Lasso Live, a special bonus episode. I know the season ended, I think, 2 weeks ago, but we have a new version of C4D to talk about. And of course, I've got with me today Rick Barrett.
Hey, everybody. And we just couldn't help ourselves, Chris and I, but to jump on a live stream for y'all on the day of release.
Yeah, I think I sent you a message at 2 a.m. last night saying, let's do the stream, because I wasn't sure if we'd be able to pull it off.
We are both super busy. Chris has the half-res event this weekend in Chicago. Yeah. I unfortunately won't be there because I'm on my way to IBC. I leave tonight and hope to see a lot of you there. This may be a little bit shorter than usual because we're both super busy, but we're excited to talk about some of the great new features in the release and answer your questions.
Yes, exactly. And I think we've got Rick for about an hour, and I might actually wrap it up at that point as well. But Rick, we've been seeing you a lot more often on these streams, and that's because Maxon has been releasing a lot more updates lately.
Yes, super frequently. We had the 26 update in April, 26.1 in June was a little bit of a surprise. It was more than our normal service pack. We actually included some features there. And then, of course, 2023 today. So yes, there was a little bit of confusion on the video. Just to make it clear, we're shipping more frequently. That's why we're changing the version numbers. So you'll see more and more updates from us on a regular basis. So we get to have more fun like this on every few months probably.
Definitely, and it does go to. I mean, how many releases came out in the last 12 months? Was there 3 in that window?
Well, this is the fourth feature-bearing one.
Yeah. So, yeah, huge. I mean, and it goes to every one of those launches. I feel like if you took your classic 1-year release and divided it into 4 parts, there's a lot more in each of these sections than there would have been. So I think we've had more content in the year than we have maybe at any point.
Yeah, and it's been super exciting. The development team is running on all cylinders. We had, a few areas like the Redshift transition and like the simulation stuff and even some of the modeling core stuff where we were doing a lot of work in the background. And the great news is that a lot of that core functionality work has been done in the background, and now we're just able to deliver some great features on a very regular basis.
Exactly. So we might as well start jumping into it. If anybody has any questions about anything, then we've got Rick to give us some answers from the inside, anything he's allowed to tell us, and then we can just tackle some of the different features. Between me and Rick, I think we've got demos for pretty much everything. So start asking those questions. Also, anybody who might be hanging out new on YouTube or on Twitch, make sure that you can just follow for free on Twitch, and you get an email every time I go live, so it's just a good way to not miss it. Subscribe on YouTube, and you also get updates whenever I go live there. And just to throw it out there, if you have a Amazon Prime subscription, you get a free subscription you can give to somebody on Twitch. So that's a great way of essentially supporting Rocket Lasso without spending any extra money. But anyway, let's jump into some of the features. Dean's got a question. He'd like to know how to put color vertex maps on specific objects within a volume.
Yeah, do you want to tackle that or you want me to?
Yeah, totally. I'll switch over to, let's see if this works. Get this out of the way. My screen with guest. There we go. Seems to be working. And we're not covering up the menu too much. I'll scoot this over a hair. All right, sweet. Opening up a new file. So colorizing different objects with a vertex map inside a volume is a thing that got apparently snuck in last second as you guys were working on it. So let's do it a little bit differently. In my video, I did the demo as part of a simulation, but let's make some text. Let's just say 2023. And I've been enjoying the workflow over and over again all the time. I've been creating text like this and then feeding it into the remesh and just allowing it to subdivide so we get decently even subdivisions everywhere. And you can subdivide it more if I go to caps and turn on the Lonnie subdivision. Yeah, that's going to look a little bit more even. So because we're working with a vertex map or a vertex color map, we're going to want a decently even subdivided count and have a decent resolution as far as the mesh is concerned. So let's say that, let's see, how would I like to do this? We could just make two different text objects, but let's just keep it simple. I'll make a sphere as well and set this to whatever mode, get a couple extra points going on. And let's scale this down and throw them into a volume. So we need to blob these out. So make a volume builder, and we'll throw one in and we'll throw the other in. So those have now gotten turned into a volume. We need to mesh those now via a volume mesh. And now you see get some detail on there. And let's crank up our voxel. And by crank up, I mean lower the voxel size so we get more detail. So in the past, if we wanted to do anything with a vertex map or selection tag or anything, we had to make this editable. It could only operate on a, an actual mesh. But now I can right click and add a other well, you said colors. Let's do a vertex color tag, but also vertex maps. And you can't paint. Painting would require the actual points of the mesh. And it wouldn't, if your mesh changed, that would break. But we have fields now, and using fields, let me select it one time. Using fields, which is turned on by default, I think now, we can feed in any of our field objects and start to drive the color. So to keep it simple, I could just make a linear field. And now you see that a color is being applied across this object on the actual points. This is the vertex color map. And we could scale up that linear field. I could switch this over to maybe a color remap, change this to any color I like, but I like setting that to gradient. And twirling this down, we get all of the Maxon presets. So let's make this kind of fire colored. And now we've got this fire color on top of it. And that would layer up on top of maybe a spherical field. And that spherical field, select it, T for scale, scale it up. And this could be applying a different color. So here it's just applying a kind of magenta color. And it's set to max, but we could set that to normal, which will just have it fall off on top of the other ones. You can see how we can start to combine these. Now, if we wanted to apply these specific colors of these models, we can always feed a model in directly. So in this case, I can say, hey, take a look directly at that sphere, and we can view it as individual points. So now every single point on the original mesh, that's why I had to subdivide those. So keep in mind that that looks like this. So subdivided, but not crazy subdivided. And depending on the radius we put on the points, you can see each individual point, and then they'll spread out. And if I go large enough, eventually they'll start bleeding entirely into each other. Now, if I go too large, you can see it starts bleeding over to the object, which might be something you want, maybe something you don't want. But we can also change it to these other modes. I'm not sure if volume will do anything for us. Volume's not bad. It's missing a few. The one that seems to work best is surface. So now it's actually looking at the surface, and we can even expand beyond the surface a little bit, but we don't have to go too far. I guess it's not applicable here, but always remember in the last version of Cinema, the curvature mode came out when it comes to the mesh objects in fields.
Yeah, thanks, Chris. I was just going to mention that. In 26.1, we added that great new curvature option, so you can use the concavity or the convexity, the concave or convex curvature in order to determine the color or directionality or values.
Well, this is interesting. It looks like the remesh is only viewing maybe one of the letters. So I'm going to just throw that into a connect. When in doubt, throw it into a connect object. So that should weld everything involved in that text into a single model. I don't even need to weld it, but it's baked down now. And we'll just have this view that one. And now we see it does see all of them. But I think that I could quickly click on curvature. Yeah, look at that.
Yeah.
So yeah, but clicking on curvature, we can now see we get essentially the outlines, every sharp edge that that text has, and I could increase that, brighten it up, shrink it down. We could remap it, we could invert it, and we've got things like concave, which is going to find kind of the dark, shadowy places and fill those out. And then I was never quite sure on what direct did. It just feels a little... What does direct do?
You know, I'm not sure either off the top of my head, but that's why we've got that great help that you can just right-click the parameter and show help.
Exactly. But yeah, so you can do these types of outlines, which is really great because we could be feeding this. I mean, I didn't even think about it, but parametrically speaking, we could be using this in a vertex weight map. And then these can be procedurally selected, and then we could do a deformer to like inflate on only that vertex weight.
Yep.
So yeah, even more possibilities. But for now, let's switch this to surface, and now we're just getting that colorized on whatever solid color. So let's make this something kind of high contrast.
We got an answer, by the way. The direct is negative values on concave and positive on convex. So if you've got the value unclamped, you can get a range of values there.
Excellent. Oh, Fritz is in the chat. Hello, Fritz. If you're in the YouTube chat, you can say hi to Fritz. He's involved in, well, he's one of the coders over at Maxon. He's
Yes.
worked on a bunch of parts. He was the lead on the volume, or the Voronoi fracture, one of my favorite aspects of cinema. And he's involved in the simulation stuff these days, I think.
Yep.
Okay, so
was involved in sneaking in this last minute feature.
Oh, that's true. That's true as well. The feature we're talking about right now, Fritz snuck in like the last week before they locked it. So anyway, you can see that I've now got this colorized whatever color I like, and we've got this one colorized whatever color I like. So let's see if it refreshes, because there's a chance it won't. But yeah, there we go. You can see now, because we're looking at these models, I can now move these around, and as it collides in, we get this nice smooth blob happening, and the colors transitioning between the two. So right out of the gate, working, didn't have to make anything editable, and now we can make these types of animations. In the past, we've had to have made this editable, and it just would have been impossible. So yeah, super cool right here out of the gate. Lots of things.
And then for those who don't know, of course, to use this, you would use it as a Vertex Map shader in the classic renderer, or in Redshift, you would use a Vertex user data. What's that node called again?
Let's see. I think it's safe enough for me to open up one. Oh, well, that's the cinema one. I didn't update my preferences here. Set that to Redshift and create a standard Redshift material.
Vertex attribute.
Yeah, beat me. Let's see. I was just going to search for Vertex. Yeah, Vertex attribute. So yeah, if you make this, then you should be able to connect over to it. But anyway, yeah, these are combining, and we can use like any of those like blending modes. So these could be multiplying, they could be overlaying, adding on top of each other. So we can do kind of a light additive mode. What would be the mode if we want to, like, would it be? No, it's not subtractive. Is there a mode that would mix these kind of the way paint would mix, or is that just leaving it on normal? I think it might just be on normal. Yeah, I'm going to leave it on normal. That's one that is giving me the effect I want. But yeah, all the stuff live. I could scale it up. We could change, if we go inside the Vertex map, we're using these individual controls on these. So I could say, like, oh, increase the radius of, actually, this is the second one, so it's overriding. So if I increase the surface here, you can see that's going to bleed more into the other one. It's got a soft fall off there. But we could leave these pretty sharp. And then a trick I like doing is making a duplicate of a tag like this. Make sure you rename it. If you don't rename it, it can get confused. And we'll delete out all of these fields and now drag the original one in. So it's kind of like it's almost like a smart object in Photoshop or something, where it's like that's its own isolated layer. And I really love using this as a workflow. So now I'm just looking at this map. So selecting it, currently it's set to nearest. But keep in mind, well, yeah, we'll leave it on near. Actually, I want to do average. That's what I want. So if we say average, then now we're looking at the incoming information and then the points around it and blurring it based on this radius. So you can see I get a nice soft transition between those two. And at any point, I could jump back to the original, grab this one and say, actually, I'd like the color to be, let's go with a brighter red this time, or maybe something that's not going to make your eyeballs bleed. Yeah, a blue's fine. So yeah, combining those, really fun. And you know, we're in the volume, so we could do things like adding a smoothing on top of this to make these blob together a little bit nicer. And there's all sorts of fall-offs and things you can do on top of that. In fact, I guess there's this even union where we can say that there should be these like, how's this go? Yeah, actually that works really well.
Yeah, this was another new feature in 26.1.
Yeah, this came out a couple months ago where as two objects meet, you can specifically just kind of blend between those two with this specific parameter. So yeah, instead of blobbing everything out, we can just do where these two are combining. So yeah, really, really fun there. And I guess while we've got the setup, this works with the Vertex colors. It also works with the Vertex weight map, and it works with point, edge, and polygon selection tags as well.
I think it's just polygon selections right now, Chris.
Oh, really? Oh, okay. Well, that's on me. I mean, that's the main one
But yeah,
polygon one's the only one.
Main one you'll need for materials and stuff.
Is there a place to find that tag, or because what I've been doing is taking a different object, making it editable?
That's what I've been doing too. Yeah. I think that's something that we need to improve.
Oh yeah, that's what happens when the feature snuck in last second. Not that I'm complaining. So yeah, let's see if this works. A super simple version is, here is a polygon selection tag, and I'll say use fields. And I would like to, let's keep it simple, make a linear field. And now in theory, this is doing a selection, but there's no way for us to see it because it's not editable, so we can't see selected polygons. But With any luck, I should be able to make a material, and you know what, I'm going to switch this back to standard. Just make a simple material, make a color, apply it, and let's see if I can get that to acknowledge only the polygon selection. What I've had is it doesn't refresh right away, but as soon as I kind of click and move off of it, I can now take this and move it, and you can see I've got a live selection on that. And I suppose, like, you know, this is looking at fields as well. So yeah, I put a linear selection on here, but it doesn't have to be that. It could also be, let me mute Slack. I'm not sure if that audio is coming through. Pause for the hour. Okay. I haven't done this before. Always dangerous to test these things live. But on the selection tag, what if we tried to drag in just that sphere? And I'll say I want to view the surface. And yeah, there we go. So now you can see I've got a polygon selection just where that sphere is. So complete control over that as well. I'm going to hit undo a few times and get that fall off back again. And just to throw it out there, oh yeah, that's hitting undo on that. We have the tag on there. There we go. We've got this nice big fall off there, so you know, we can always overlay things as well. So something I like doing is making a random field, and that random field set to overlay. Put that to normal. So we're overlaying this noise. I'll make the noise quite large, and now you can see because of that soft transition, this noise is able to influence it. Essentially, make light areas lighter and dark areas darker. So now the edge of that transition can look like a noise. Scale that up to other sides. We can even duplicate that a few times. How do we duplicate? There we go. Right click, duplicate, 2 overlays. So now as I move my linear field, I've got, it's going to be kind of hard edged on the right side, but on the left, you see I get this noise transition in based on a polygon selection tag. So yeah, Vertex Maps, Vertex Color Maps, and polygon selections, all parametric now, which will be super relevant when we start playing around with some simulations, especially during live streams where we're talking about simulations, solving problems where it's like, ooh, how do we make this part like soft and this part rigid? It's gonna be like, well, a vertex map, a procedural vertex map. Okay, I'm gonna check out the chat, see what else we've got.
Yeah, there were some questions about plugins specifically, and all of the C++ plugins will need to be updated for compatibility with 2023. So that's all your renderers, Xparticles, GSG, Rocket Lasso's plugins. I know that GSG and Rocket Lasso have already announced that their plugins are good to go and there's updated versions available. I'm not sure about the others, but I'm sure that everybody will be up to speed very soon.
Yep, ours are definitely up to date. And if you did go and download ours again right away, we made a mistake with our recall upload. We essentially forgot to hit save on the upload, so it is now fixed. So you can just re-download again. Yes, so yeah, that is all updated. What else do we got? Somebody's got a question, just is any sketch and tune renderer on the horizon? Any updates to that? Maybe you probably wouldn't be able to say. So.
Well, what I can say is that we are definitely building a render strategy around Redshift, and we know that non-photorealistic rendering is an important function within Cinema 4D. And of course in other 3D apps as well. And, you know, of course, Sketch and Tune provides a great solution for that now. There's also some great techniques while using Redshift. For instance, you know, if we want to render lines, Chris's Mesh to Spline plugin works great for being able to generate splines from the object, and then you can render those using Redshift's, you know, hair spline renderer.
Yes, that works awesome. That was one of our main motivations on those tools, is how great they looked in all the third-party renderers, especially in Redshift.
Yep.
Scrolling through, we got lots of hellos.
There were some general questions, too, about Redshift being the default renderer. And as I said, we are working towards Redshift as our render strategy. You know, there's, you know, a little bit more that we want to do from the integration side and the performance side for Redshift CPU before we fully flip that switch, but that is in the future. You know, I think as you see the things that we're doing and the way that we're integrating Redshift, clearly we're moving towards that direction of Redshift being the default renderer for Cinema 4D.
Yes, very exciting. Yeah, everything's becoming, I mean, even in the interface right now, like if you switch over to Redshift as your renderer, then the lights and the a bunch of the environmental objects, they shift over to Redshift automatically for you. The new OCIO ACES workflow like is tying directly into Redshift straight from like the main project menu. Yeah, exciting, and you know, Redshift is a really awesome renderer. Scrolling up. Ulf sub, thank you for the Prime subscription. It's very appreciated. Let's see. And I mean, for anybody who is using, Redshift inside of Cinema, which of course Redshift just comes with Max on 1, right?
Well, Redshift comes with every Cinema 4D subscription for Redshift CPU. And then, of course, if you have Max on 1 or a Redshift GPU subscription, you can take advantage of the GPUs on your system. We've got full support for NVIDIA GPUs as well as Apple Metal. It works great on my Apple Silicon. And then we are working on support for AMD graphics cards as well on Windows. So yeah, lots of GPU support there if you have Max on 1 or a GPU solution, and that'll give you the fastest performance with Redshift.
Yes, excellent. So let's see. I want to tackle questions as they come in. So if anybody has any questions specifically about the new 2023 version, please throw them into the chat. Otherwise, me and Rick can just start demoing off some different scene files that we've got. Did you have any files to show, Rick? A lot of people are going to have seen my video. Does anything jump out at you? Maybe something that should be getting a little more attention?
I mean, I think Symmetry is getting a ton of attention, but I think it's worth us chatting about it some. So yeah, we can play with Symmetry.
All right, I'll switch over to your screen. Switch a setting. Actually, see if you can pop open the hub again. Yay, it's working. Okay, that was easy.
Okay. Cool. So yes, the Symmetry Hub gives you all of the options for whatever tool that you currently have active. And you do have the option here to pin it so that it will stay on top. So that's a cool function that was added to a couple of our managers, like the Task Manager has that as well, this option to pin it. So you set up your Symmetry. Of course, you can show the planes of Symmetry, and you can change your workspaces. But the beautiful thing about this is that once you turn it on, it really just works. I mean, you can make a selection. You can see that that's mirrored on all 4 planes. We can do an extrusion. We can come over here. Let's turn off Z or Y actually, and select these. And that fit circle tool is super awesome that we added in 26. So we can just turn on fit circle and create a circle. We can extrude this out, and then bridge tool. Now, when you bridge, what you're going to get by default is not going to work because you're trying to bridge between a selection and a virtual selection. So what you need to do is symmetrize the selection, which basically sort of disables the symmetry and turns the selection into a real one. So the shortcut for that is UV. And I know that Chris and I both mentioned the shortcut because I think we know that that's one we're going to be using a whole lot.
Yes.
And so you can bridge right across here. And then, of course, the bridge tool in 26 got these great updates where you can actually bridge with curvature. Awesome. So really nice things that you can do here with the Symmetry system. And then you have the option to actually bridge or use topological symmetry too. Chris did this with he did a really great model with turning a T-Rex into a dragon. I've got a shark here. And here in topological, what you can do is just go in and you can select an edge, and you can select multiple edges or just one edge, and basically define that as the selection for the symmetry. And then when you go in here and do your modeling, you can see that all of those selections are mirrored onto the other side, even though this shark is completely bent and planar symmetry would not work. It works great here. And Chris showed this in his video as well. But the cool thing is that it's not limited to something that would be symmetrical necessarily. I mean, you can go in here and select a couple edges on the fin, define selection, and then you can work on symmetry just on the fin.
Yeah,
just like
super
that.
crazy. Yeah.
So you can do some very local symmetry actions that way. And then, of course, when you're using planar symmetry, you're not limited to the world XYZ. You can use the object XYZ. You can also actually use the work plane. So Cinema 4D's work plane features and how flexible those are become way more important now with the advantage of the symmetry functions.
Yes. I wasn't even thinking about it in the context of every time I did the topological or topology mirroring, the symmetry is like so intuitive. Like it's so quick and it just works the way you expect it to. So you don't have to think about it. Like it just works on both sides, even if it's an asymmetric object. But I wasn't even thinking about it in the context of, I was always doing it on like, oh, I'm a nice clean flat plane. But I didn't think about the idea of like flipping it onto like one other side, like the fin here. Like that's really cool.
Yeah. Yeah.
That's awesome.
Also, I mentioned that the hub is pinnable, but of course you can also dock it in your interface as well. And so that's available as well. And everybody say hi to Luca in YouTube chat. He did a lot of the great work here on the symmetry.
Excellent. Welcome, Luca. Yeah, I'm super digging the symmetry. The shortcut is Alt W just to turn it on and off, so very seamless to be able to activate it as an entire mode. And it doesn't just work on like polygons, points, and edges. It works in like vertex map painting. It works on like subdivision surface weighting. It'll work with almost every single modeling tool. It works with the sculpting tools.
Yep.
So yeah, really powerful, really intuitive. I mean, it's one of those things that I don't use a lot of other software packages, but it's one of those things I didn't know I was missing it until we have it now, and it's like, oh, okay, this is cool.
It is just really, really intelligently implemented and really fantastic to use and play with. Here we have a crate that was modeled out much better than my version. And this can show us how we've got the symmetrize command. So we only modeled one corner of this crate, but we can go into the symmetrize command, and you've got a cogwheel here, if I can hit it. You can link the settings here with the hub. That's useful so that you can just run the command and not worry about popping open the cogwheel. Or you can go in and set specifically where you want it to copy. So positive XYZ to minus XYZ, automatically do the welding, hit OK, and give it a second to calculate.
Did it have to be in polygon mode?
I think we do have to be in polygon mode.
Yeah.
So we'll try that again, and there you go.
There you go. Instant.
So now you've instantly turned that one corner into the full crate.
Awesome. Yeah, I mean, yeah, super quick, super intuitive. So yeah, just another seamless tool to add into the dramatically improved modeling tools we've been getting over the last year.
Yeah.
Somebody's got another clarity question. I know you mentioned it already, but now that you got rid of the R and the S in front of the name and you're going with a yearly name, does that mean there's going to be less updates?
Not at all. It's actually more updates. So this allows us to easily go from 2023.0 to 2023.1 to 2023.2, as many updates as we have within this year until next September. Presumably, we'll go up to 2024. And so this is actually to allow us to ship more frequently, because as we were shipping now, we only had the option of upgrading the version number entirely, as we did from 25 to 26, and having those version numbers inflate very quickly, or having something be a .1 like 26 to 26.1, which didn't always reflect the fact that there were some great new features in there. So basically, anytime you see that second dot, up increment, that's going to tell you that there's new features. And then if it's just a hot fix, you'll see like 2023.0.1. That'll tell you that there's just bug fixes.
Yep.
But we do expect to be shipping a lot of features. One of the great benefits of subscription is that we get to deliver them as soon as they're ready to you. And so we're going to be shipping much more frequently.
Yes. So yeah, very exciting. I mean, before it was like, well, in a year there was an S and an R, and it's like, well, what happens if there's a third release? It's like, what does that come under? So it ended up being like 26.1, But yeah, now it can just be the year and the decimal point.
Yep.
So yeah, very exciting. Welcome everybody to the chat. We got a lot of regulars. We got some new people. We got some Maxon developers in the house. So welcome everybody. Luca, if you're still in the chat, I'm curious, when it comes to the topological symmetry, is it counting polygons? Is that how it's actually figuring that out? I'm just curious mechanically what it's doing.
That may be more of an answer than he can type into the chat.
Maybe. Well, the simple version. But let's see. Well, yeah, there's some people asking questions, and there's as far as talking about. I know everybody's always excited about future things, but it's always going to be difficult to talk about future things. Like I'm never allowed to talk about any details, even if I might know something that's coming down the pipeline. And even Rick is going to be very limited in the things that he is able to say, because somebody's asking about like the idea of maybe proper rigid bodies being integrated in the simulation system. But I mean, right now, clearly, Maxon is actively working on all the simulation stuff, and there's huge updates to it in this version.
Some questions about ASUS.
Yes. Well, it's good that we're on your screen because my computer, I think my video card might be dying or something because it just does not like streaming and doing Redshift or recording in Redshift. So it was very challenging to record my video, but Rick can demo this a little bit better. And I think Rick understands ASUS at least slightly more than I do. So,
I don't think anyone really understands ASUS, but I think some people fake it better than others.
I think Chad Ashley might understand it, but he might be the only person.
Yeah. So yes, this is a scene that Stu put together for me. He's another one who I think at least somewhat understands it. And fortunately, we do have some people in-house that understand it and have been able to pull this together for us. Of course, all of the third-party renderers and Redshift have implemented ASUS and OCIO over the past few years. And it was past time for Cinema 4D to have a native implementation. So we're excited to include it here. And you'll find it just down here in the project attributes. So by default, you're going to be in basic mode. We don't want to screw with anybody's existing workflow. This is going to give you the same old standard linear sRGB workflow that you're used to from prior versions of Cinema 4D. When you're ready to move into OpenColor.io, and OpenColor.io doesn't have to mean ASUS. It's just the vehicle by which ASUS is delivered. But when you're ready to move into OpenColor.io, you click this button to switch to OpenColor.io. And what you're going to see is that the scene immediately changes. Now, all of the colors that are stored within your materials and within other aspects of your scene are all stored right now in sRGB space. Once you can move into OpenColor.io, they're going to be stored in render space. So what you need to do is convert all of those sRGB colors into your active render space. Now, if our render space was actually scene linear, which we have a preset here, so you can switch to sRGB, it would be basically the same. But if we go into ASUS, what we need to do is convert the sRGB colors that are already provided and stored in the scene into ASUS CG. So we'll hit OK, and that's going to convert those colors back. Now, it's important to keep in mind that ASUS has a different color gamut than sRGB. And really any of these other, render spaces that you would use, like ASUS 2065 is a wider gamut than ASUS CG even. And then, of course, even that gamut that you're rendering in, then you actually are going to clamp down into a view transform. And the ASUS view transform is sort of where some of that magic happens with ASUS. So it's important to keep in mind that your colors are going to shift even once you do this conversion. And as you're developing, you don't have to do the conversion if you develop a scene from the start using OpenColor.io. It's only if you're converting a scene from an old file. But then as you're building out your scene, what we've done is modify the color chooser so that you have the option to choose colors either in sRGB, which is the workflow you're used to with third-party renderers and Redshift prior to our implementation of OCIO. You can pick the colors in render space, You can pick raw colors, which is useful if you're picking a color for data purposes, like you need to pick 50% gray, or you can pick display. Now, what display does is it actually does an inverse view transform. So it's looking at what you have set here in your view transform, which is currently ACES, and it's trying to invert that in order to make it so that the color that you choose within the color chooser is the color that you get after that view transform is going to be applied on the render.
So it's taking what your eyeball sees, reverse engineering it to be proper for ACES, and then to you it was seamless.
Right. So that it's really useful if you're trying to get closer to a brand color. Now it's really hard with ACES because of the gamut and the inverse view transforms and everything to actually preserve a brand color. And that's where it can come in handy to use something like Magic Bullet Looks and its color shifting technology. But in the meantime, that display picker will allow you to pick something that's closer, that's going to more closely represent the final color.
So I want to pitch this question out, which I've already asked you multiple times and other people, and I think I go by Zach is hanging out in the chat. Maybe at some point him and I can do a team up video where he'll explain to me some of the additional details, because he's also I'll say our local expert when it comes to this stuff as well. But for somebody who's not familiar with OpenColor.io or ACES, what's the point? Why would you want to do this?
Well, the main point behind OpenColor.io is that it provides a framework that's supported across multiple apps in order to ensure that there's color consistency between the apps. And the OpenColor.io, you see right down here, you have the option to choose a config. We've provided sort of a basic config that's the same one essentially that Redshift had shipped with prior. But studios will have their own configs. And that will allow them to ensure color consistency across all of the different apps in their pipeline, both 3D DCCs and actual compositing applications, so that they have unified color throughout. What we have is a basic Maxon OpenColor.io config, and we're using that to create a unified color pipeline around all of our Maxon apps. So Cinema 4D, Redshift, and Magic Bullet Looks. Now you can deliver the same color thanks to OpenColor.io. Now, also OpenColor.io is the vehicle through which ACES can be delivered, because ACES CG is one of the color spaces that is available in these OpenColor.io configs. And people love ACES because it allows you to get a more sort of natural film-like fall-off of lights, specifically, than you get in traditional scene linear.
Somebody's got a question. Is this new Maxon or the Cinema 4D OCIO different than the one that's already been shipping with Redshift for a little while?
It's not different, but it's the same config, and Redshift is rendering OCIO the same way it always has. The difference is that it's now native within Cinema 4D, so you have the settings in the color management, you have the support within the color chooser to pick colors based on the rendering space or the display space, and then within the picture viewer, when you render these things out, you have the option to modify the view transform there, which is actually going to allow the Cinema 4D picture viewer to show you the same image that you would see in the Redshift render view, which has been an issue in the past.
Excellent. And I think right now in the Redshift render settings, you can use kind of the old style in Redshift or the new one. It defaults to the new one, but you can convert to the old.
When you open an old file, it's going to use the old settings, so that, again, we're trying to keep everybody's workflow and files consistent. We're not changing things without your permission. But once you convert to OpenColor.io, it's going to use Cinema 4D's settings by default.
Somebody's got a question. Does this affect standard and physical as well?
Yes, OpenColor.io is implemented across all the renderers. Third-party renderers can take advantage of it as well. They will need to, obviously adapt their code in order to do so. So you may not see, the initial 2023 versions of the third-party renderers support it, or maybe you will. But yes, standard and physical fully support OCIO as well. There's even an OpenColor.io transform node available within the standard node space for standard node materials. And then with regular standard renderer, you have the opportunity to set the color space for your textures as you're creating materials. So if I were to bring in a texture here, let's see, let's grab a texture. We'll just grab an HDR here. We'll grab one that's already downloaded. And you can see here that you have the color space option here, which by default is automatic raw because it's an HDR file. But you can choose, to identify these textures as already being in the ACES color space or any of some popular camera spaces or scene linear sRGB.
Yep. And somebody's asking if you go back to your file and A/B test the pre-ACES and post-ACES.
Yeah, the A/B tests are a little bit tricky to do. We've done what we could on the picture viewer to try to embed the actual settings. I think it's going to work a little bit better if I switch here into 8-bit so that it can bake down the setting here. But
you might need to revert because you already converted.
Right. So this is the converted ACES version, and let's just open up we'll revert to save project. And this one was set up with Redshift, but if you look in here, you will see that, again, we bring it in with the settings it had, and it was using scene linear sRGB. So this is basically without ACES. And we'll render again. And that's not what it looked like before. So I think that the picture viewer is transforming it.
Yeah, I'm still wrapping my head around it. The extent of my knowledge on it, it goes to and the immediate thing you can see is that colors will get washed out and they get blown out and they don't transition very well, and this just respects that a lot more, where you get less banding, less bloom when it comes to the colors.
So here we go. This is a better representation here of the before after. So you can see here that these colors are getting very blown out, the blue and the red here, and the way that they're interacting with the balls. And
the shadow on the red one, you can see like a really bright bloom effect, right, like a really harsh transition.
And when we shift to the ACES version, you can see that we get much better fall off here on those lights.
Yeah. Yeah, so less blowout, better, really good saturation, but without the saturation blowing out.
But again, you're not talking to the best people, yes. The best authorities on ACES and OpenColor.io. So
this is you and me parroting what people who know what they're talking about have said about the system. So
I have a feeling some of the real rendering nerds are going to create some great content for us here in the next few weeks as they get a chance to play with us some more.
Yes. Justin is saying the modern version of Make Those Colors Pop. Let's see. We've got about 15 minutes left with Rick. Does anybody have any questions that we should cover specifically while Rick is here? And I imagine we'll start diving deep into some simulation stuff once it's just me. So everybody look forward to that because it's my favorite part of the update because it's just so much fun.
Yeah, the simulation stuff's fantastic.
Let's see. What are some other things to talk about?
There was a question about the symmetry generator and whether it has a purpose with the new symmetry. I think that it still definitely has a purpose because it will allow you to perform symmetry in a non-destructive way.
It's procedural symmetry.
Yeah, but it's, for a lot of what people were using the symmetry generator for in the past, which is just to model with symmetry, obviously the new symmetry tools are going to provide you with a much better workflow for doing that now.
That's still very difficult to see. We have to see the entire question. Just
Demis
repost the
is
question again.
volume
Repost the question again if we
shading
missed it.
question. I'm trying to find.
Yeah, I'm scrolling up and I'm having trouble.
We did show blending between two objects with the volume builder. That's the question I see here.
I think somebody said, is it possible to blend more than two objects? And yeah, you could blend unlimited. You just feed more models into the field, and anything you put in the field could be used to manually blend additional colors.
Mm-hmm.
I wonder, I'd have to experiment with it, but I wonder if a Vertex color map would respect the color of clones as an input. Probably not, but we kind of need to check. Like take that on as a color through MoGraph tools. But I'll do that in my own time. But anyway, let's just start talking about some simulations.
Yeah, let's jump into simulation.
And I'm going to switch to my screen. And I might have a couple of specific questions for you. And if Fritz is still in the chat, he might be able to cover some details as well. Okay, switched over here. Hopefully that's working. Open up a new file. Okay, cool. I mean, I don't want to just walk through the same demos that I did before, but there are a bunch of cool new features. And the super exciting part when it comes to the new features is how everything layers on top of other things. Where, well, let me just point them out. We've got this new target length slider, and it also has a vertex map that we can control. And that enables us to, it's essentially the equivalent of rest length from the old Softbodies. But it's even more powerful than that. It's very kind of clean in the way that it works. I mean, I'll open up the one demo file to just give quick context on it. Demo symmetry length. So here I've got this head from the assets browser, add a very quick simulation cloth, and this one will automatically kind of pop to the new length you put in there. So watch, if I put in an extra big length and hit play, you see it's going to pop to that new size instantly, and it kind of self-intersected. So you want a keyframe to get to that point. So let's start out at 100%, and then over the course of 100 frames, I'll have it shrink down to 35%. So now it has some time to do that transition, and as I hit play, you'll see that this will shrink, and we get really awesome like vacuum forming like instantly around this model, working really well. Something I was kind of shocked at how robust this was kind of working is if I give it no transition and hit play, it still kind of perfectly worked, even as quick as that went. So yeah, that's a super basic version. But something I didn't do in my video was we could be controlling this with a vertex map. So just as a random thing here, I'll get rid of the head. Let's create a plane to be a collider, drop this down, and I'll just say that the ground will be a collider, and the sphere is going to be changing its target length. And I'll say that it should be driven via vertex map. So let's add on a parametric. Is that the right wording to use with something? Because we haven't baked that down, but this isn't like a parametric vertex map. It's on a parametric object. I just was having trouble thinking of the wording.
Yeah, I mean, that's how I'd refer to it.
Yeah. Anyway, I'm going to put a random field into this vertex map, make it large enough that we can see some differences there, and give it some animation speeds. If I hit play, let's go fast enough I can actually see the difference happening. So you can see how that's moving around pretty well, maybe a little slower. So now inside of our tag, I'm going to drag the vertex map, and we'll see if this works. And I think that actually right now it's at 100%, and we have to set the target minimum length. So I'm going to say that when it's at 0%, it should be actually thinking it's 25. So if I hit play, you should see that instantly shrunk to that size, but now it's I probably went too small. Let's not go quite that far. Let's say 75. Now, because of, I don't know if it's early implementation or a limitation, but the vertex map's not going to refresh for us right away. So we just have to tell this tag to refresh somehow. So I'm just going to keyframe some, whatever parameter. So I'll say like the mass, I'll keyframe it and force a refresh by setting that to like 1.01. So now it's going to keep updating. And now you can see that my animated map is telling this to change. It's getting larger and smaller as those animate. Let's have it go bigger. I'll say it's going to start stretching out more. I don't have balloon on, do I? Oh, I guess I can't go above 100. So we have to start out, let's start out at something larger, and then we'll have the minimum go down. So that would actually be the way to do it. So you can see I've actually got different lengths pushing in and out on the length. So and the way to describe it, I think, is any given edge, like this edge right here, there's actually kind of like a spring connection between those. They're related. And this target length is saying make that connection longer or make that connection smaller. So that's just a super basic thing on target length. But I didn't want to get trapped just talking about target length because we got a bunch of new features here, including the very exciting stickiness. And the stickiness I have found to be very, very intuitive. I'm going to actually pop open a file I didn't demo. Exploring, I might open the wrong one here, but let's try. Not that one. Follow with pins. Sticky. Ooh, sticky wall. I think that might be one. Okay, so what do we got here? Well, I guess I'm jumping to something a little bit more advanced right away, but these essentially, I've got these two spheres are pretty rigid. They're not very squishy. And I made this wall out of kind of it's like cloth right now. And I've added, well, actually, let me just turn off stickiness on all of them and then we'll start activating it. So 0 stickiness, hit play and you see what we've got. So those are going to bounce and then they're going to hit this kind of loose piece of cloth and they just kind of bounce off it, wrinkles and it falls. But now let's shift this to, I'll undo to see what settings I had on there. So now I've got stickiness of 111, and on both of the spheres, I've got a stickiness of 5. So this cloth is now very sticky. So now as I hit play, those are not sticking to this because it has a stickiness of 0. But as these hit this, they are now sticking to it. And look how it pulls the cloth around with it, actually like sliding off. Like it just works so quickly and so intuitively there. Like it's very exciting. I'm going to open up like my most advanced file here, just to show some of my exploration and how kind of crazy you can get, where demos, graph. So here was the final file I was playing with, and I'm still tinkering with this, but you'll see that I've got this hand, and I'll show it again. I'll delete my soft body. So I've got this hand, and it's going to be keyframed. You see it's animated, and it's going to essentially just hover across the table. The fingers just pass right through it, and it moves up. Very stiff, terrible animation, like no smooth keyframes or anything. The F curves are terrible. Now, if I undo, I can bring this tag back in. And now we are using a bunch of the new features, including the stickiness. And we'll talk about the mix animation in a second. But check this out now. Changing nothing except for adding on the simulation cloth tag. This hand is now grasping at the cloth, picking it up. And there's all the secondary movement within the hand because the soft bodies are allowing it to be dynamic. So like absolutely crazy. It's so much fun getting this basic idea. And I think there's so many applications for this where you make part of an object a simulation, part of it like a soft body. And you can make it a pretty stiff soft body. So it's kind of pliant, but it still will move. And man, this is going to open up a lot of possibilities. I think my best demo here was these hands. And I know I showed this in the other video. Actually, before we get there, we got to establish the poles as well. So what's a good demo for, actually I didn't do the elephant. So from scratch, I'm going to open up a file and let's again make a floor to collide with, simulation collider. And let's bring on our old pal, the elephant.
Chat's pretty amazed, by the way, with your hand demo. And well, they should be. That's really amazing.
Yeah, it kind of went to like, I wonder if I could do this. And it was immediately like, oh my goodness, it's working. So yeah, we've got a lot of exploring to do along those lines still. That was just like an early test. So I think we're going to have a lot of fun with that. Okay, so we've got our friend the elephant, and let's turn it into a soft body. So this is all default settings. If I hit play, actually, let me change my simulation settings to CPU because my computer goes faster with the CPU. Hit play, we'll see the elephant fall, and you see it's a soft body, it's falling, it's collapsing. If it was more heavily, well, first of all, there's a couple settings in here. It's a little bit bendy, it's not stretchy at all. We could say get rid of all the bendiness. You see it's going to be decently rigid, but it's kind of, I don't know. It's a very particular type of rigid. You know, I think I might want to subdivide the elephant by 1 just to get more subdivisions. So I'm just going to do US for a single subdivision there. Let's do U shift S so I can say a smooth subdivision. Okay. So now, even with 0 bendiness, you're going to see that as it falls, it's going to still be decently squishy because even at 0, there's still gravity pulling down, and every single connection, every single polygon still is being forced under the weight of gravity, under the weight of the object to bend a little bit. So this makes perfect sense. But now there's a brand new setting under soft body, and it is the ability to add poles to a model. What does that mean? Well, if we turn on soft body, you're going to see a whole bunch of connections shooting from one side of the model to the opposite side of the model. And each one of these is, it's almost like a little tent pole inside of the model. And it's connecting from one side to the other. And we can tell it how stretchy is that tent pole. So that's the softness. And in this case, I'll say 0. And we can say how long those tent poles are relative to their current length. And we've got a bunch of additional settings like how many are there per point. Like right now, every single point on the elephant is shooting out essentially a laser to the opposite side of the model and then seeing if there's a connection to be made. So just by adding in these tent poles, and I'll leave this all default, now when I hit play, and now, oh, look at the structure. Like, it's so good. Like, look at the structure you can instantly feel in the elephant. Like, look, this leg clearly has a shape that it wants to maintain. And this is essentially throwing in at default settings. So immediately that gets really exciting. The something to point out is the icon is updating depending on what you're doing. If we turn on Softbody, the icon changes from a shirt to a jellyfish. And if we change it to turn on balloon, it's going to look like a balloon. I'm not sure which one's override. If I turn Softbody on, apparently it turns into the jellyfish. It should be a ballooned out jellyfish. You have to make like dozens of icons of every possible permutation. But anyway, we can make additional poles here. So we can say, hey, there's actually going to be 3 tent poles per point. We can control how much variation there is. Like we can have them be very angled, so it's going to like kind of cross over the entire elephant, adding even more structure. But then we can also limit the length. What I like doing is going down to 0 and increasing it until I get to the point I want. Right now I can only do very short ones, but I could say I don't want it going all the way from the rear of the elephant to the front of it, so I won't let it get that long. But now we've added all of this structure, so now hitting play, that should be able to be even, you know, more stiff. And now you can see that even the trunk doesn't want to bend too much. And so this isn't a rigid body, but it's a soft body with structure, which is really cool. And this is something we never had with the old soft bodies with Bullet. So that really cool on top of everything else. But there are some additional options in here as well. I can't think of a better demo than the one I had sort of done. So well, super quick to set up. Again, we'll just make the plane, right click, simulation, collider. And yeah, I'll do the text one because I kind of like seeing different objects combined. So here's the exact same concept. So I did show this in my demo, but let's just say RKT this time. I always like having a nice beefy font here. Let's give it a little more depth. And we'll do that same trick where I will get some nice even polygons by setting this to Delani and subdividing uniformly. So, you know, everything's got a similar poly count. Feed that into a remesh. Now we get nice even subdivisions on that overall. Maybe not quite that many. I'll drop it down to 50%. Okay, cool. So that's going to be our mesh. And, you know, I'll throw that in connect object for good measure just to make sure it's all baked down. So right clicking on that, say simulation cloth. And let's make a different color on there. Why not? And now, if we hit play, it's going to fall, and you'll see each letter. Let me change my CPU. Now, if I hit play, we're going to see that fall. They all squish, and they are, you know, they have no structure internally, and they're completely independent. They're just kind of flopping and falling all over the place. So the basic version is we can go back in here and go to our soft body and say, add a bunch of poles in there. We'll leave it default, except I'll say no softness, so maintain your current shape. And now when I hit play, you're going to see that there's structure that didn't even want to fall over. Like these are it even stayed upright, which is pretty impressive. It's, I think, a good idea when it comes to those tent poles to like not put too much bendiness. That will maintain the shape a little bit more. Yeah, you can instantly see that these look nice and clean. Where, just to show you, if we make it very bendy, those tent poles are like stiff tent poles. But if we say, yeah, but you're very bendy, you're going to see that everywhere that there's not a tent pole directly, that's like, well, I'm going to fall over and wrinkle then. There was no support in this particular spot. So it pairs very well with no or low bendiness. But in any case, I did want these to fall in a slightly more chaotic way. So I'm going to, actually, we'll just pull it up in the air and tilt it over. So if I play here, we should see that these letters are acting very independently. The T is falling away and off entirely. They didn't fall forward or anything, but that's fine. So now let's do that same thing where I say I want the lasers to fire out from the front and back side. And now you can see that we're getting some connections in between the letters and even, you know, structure in the different bits of the K. So hitting play, now we can see that the T is going to be stuck hanging out relative to those original letters. So we've built a relationship between all of those while they're still allowed to like bend and wiggle and behave like a soft body. So again, this is just the poles, and they're very intuitive. Like I haven't had to like give any of these a second thought. Where it's just like, okay, like create some tent poles, interconnect them. Like there they are. There they go. I haven't played too much with adding softness to them because to me it always goes to I want all structure. But yeah, if we add some softness in there, I'm gonna go like overboard. Let's go like 1,000. So these should be really squishy. And yeah, we can definitely see these are all bouncing around. They have a little bit more life to them, so there's more energy to them. But yeah, man, I love these poles added in.
It's worth pointing out there too that you can actually use fields to set the directionality of the poles as well. So if you want your poles to be vertical, and allow the soft body, rigidity to be more vertical and the bendiness to be more horizontal, you can do that.
I didn't even think about that. I was just thinking of it as a direct way to control it. But yeah, we can go very horizontal here. It's going to be a little bit weird, but that should mean they're more vertically squishy. Boing, boing, boing. Yeah, that's cool. I didn't even think about that.
There's probably some cool uses there too with things like the curvature field or even using, spherical fields and things like that to have things be squishier on the outsides and things like that.
Yeah, a little bend goes a long way. But yeah, I mean, yeah, the combinations here get insane. Controlling this with a field, controlling all these different parameters with Vertex Maps.
Yep.
You can even see in here that we could control the softness with Vertex Maps. So one letter could be squishier than another. We can change the target length of these different. I'm not sure how that would map onto them. I guess it would just be the point they're based off of. I wonder exactly mathematically how that works. But almost everything ends up having like a vertex map associated with it. So like a particular pole could be like, oh, I'm going to get more like lasers, a particular point could get more lasers shooting off of it. Somebody's asking if this is based in any way off of Ricochet. And no, it's completely unrelated. These lines don't render or anything. And it's just showing where the collisions happened. But yeah, I mean, vertex maps controlling every single aspect of this. So it more goes to, it's getting to be such a powerful overall system that it more goes to like, oh, what do we want to create? Okay, here are the proper ingredients. Instead of being like, well, here are the limitations of what we have. What can we make within those limitations? So yeah, it's really opened it up. So things are going to get super crazy. So I know, Rick, you're probably going to have to bug out here. Is there anything that you want to add or that I should tackle for you to give more information? Otherwise, I can continue if you got to go.
No, I do need to take off, but just to encourage everybody to download from Maxon app. Make sure you get the newest Maxon app, by the way. We've been working on some of the licensing issues and trying to make that more and more robust. Download the latest version from the Maxon app. And, of course, we've been talking about Cinema 4D. Worth mentioning, Redshift has the stack material support, and that's available in all versions of Cinema 4D with Redshift 3508. And also you have great features in Trapcode and Universe, new sprites and presets for Universe. And then, of course, Forger on iPad has added some great new features. Almost the entire Cinema 4D modeling toolset is available now on iPad via Forger. So lots of great stuff across Maxon One. And yeah, it's been great to chat with you, Chris, and to chat with all of you in the community. And yes, if anybody's at IBC, stop by and say hi.
Yes, totally. Thanks as always, Rick. Thanks for sharing some of the new features and for all the great work that Maxon is doing, improving Cinema 4D. And yeah, of course, there's lots of stuff across the board on all the different apps that Maxon has under their umbrella. I'm, of course, always going to focus on Cinema 4D and then some on Redshift. But yeah, thanks for coming on, man.
Yeah. Thanks for having me.
Excellent. Well, talk soon.
Okay. Bye.
Bye. Let me switch over to just my setup here and end the call. Excellent. Okay, that should be all good. All right, well, let's continue. There is definitely more to talk about when it comes to the simulation stuff. Could we have these poles as spline objects? No. Could you paint the fields to set the length of the poles? Tobias, you can't paint a field. It goes to, you have to use field fall-offs and things like that. That could control them. Or you could make your mesh editable, and then you could paint the vertex map, and then that would also work. So it depends if you want to be procedural or not. But I've got more to show off there, and if anybody has any crazy ideas, please, mention them as we go. What I would like to talk about here, and let's do it, I'm going to do it in a very basic setup. is it appropriate to do? There's even a couple demos that I wish I had done, but I didn't do. And that is, I'm trying to think of a way to do it without the T-Rex, because I use the T-Rex in my video, but it just is such a great animation. Maybe we can just move straight into the hand file. So I'm going to pull in this file, and let's delete these tags off and start talking about a great additional feature. Let's turn those off as well. So here's just a collider plane. Here's just a nice low poly hand model. I stole this off the Zygote human, but it just worked really, really well for these demos. So let's talk about the last major feature inside of the simulation stuff. Oh, and by the way, the length setting and the stickiness is also in ropes as well. But let's just take a look at this hand. And I've got some keyframes on here. They're terrible keyframes, just linear essentially. You see this hand's going to shoot down, it's going to crash through the plane, move up, and then move off to the right. So moving very quickly, very rough. And there's no animation within this hand whatsoever, except for the overall model moving. So let's just work with the pink hand for now. Right-clicking, I'll add a simulation cloth tag. And yep, we're on CPU, and there's gravity. So if I hit play now, we're going to see that the animation means nothing. The hand is just falling via the simulation. So it fell, it collapsed, there's no structure whatsoever. So, well, like we could, I guess let's go to the new features. Under mix animation, well, a whole brand new tab, we have mix animation, and there's 3 different ways of mixing essentially your keyframed or deformed mesh animation with the soft bodies. We can do it with pins, with forces, or by following the shape. So in this particular circumstance, only some of these things will be relevant. So with pins is very powerful. What's a good way of showing this? I'm going to turn on with pins, and currently it's saying that every single, here's what pins means. Every single point on this model kind of has a soft body representation, and then you've got that original model doing something. We know the original model is just like crashing through the ground. So right now we've got cloth turned on, and we've got pins with influence of 100%. And at 100%, it's saying every single point you have to be exactly where the animation said you should be. So if I hit play, well, let me show you. If I turn off pins, hit play, you see it just falls with gravity. That's all that's happening. But if we turn on pins with 100% force, now you're going to see that it goes back to the keyframe animation, just 100% doing the keyframe animation. But if we start pulling the influence down a little bit, then now you see that, well, it's roughly hitting the ground. We might have to go relatively light with this for it to actually, or actually pins might force it through. Well, okay, there you go. Now you see it did move down, and now it's moving up with the animation, but the pins are being forced into a particular position, and they're still passing through. So this particular setup, not super useful, because we're applying the effect everywhere. We're uniformly saying everything has to go exactly where the animation said. But where things can start getting interesting is saying not everything has to go along with it. So I've got a vertex map painted right here. And so this is saying everything yellow, everything at 100% is saying, yes, I am cloth, I'm a soft body. And then everything red at 0% is saying, no, I'm super stiff, I'm going to be pinned. So let's apply that vertex map to these pins. So essentially only the very back of the hand is locked in place. So now when I hit play, we're going to see the hand gets yanked down, and then the back of the hand is going to get yanked upward and then yanked off to the right. So you see the rest of it's become just like this floppy glove. And you know, that could be exactly what you're going for. We could add more bendiness on here. We could add a bit of stretchiness. And now the whole thing can just like flop down on the ground, get yanked up, and it's just going to behave like a rubber glove that's empty. But let's reset those back down to their defaults. And let's apply some other things that we've learned. Let's apply the pins. Let's apply the poles. So going under soft body, let's activate these and add some poles. I'm going to say that there's no softness in them. I don't want them to be squishy. And we got a bunch of poles. I want there to be maybe even a couple more. I'll give them more variation, put the max length down, and then stretch these out because I don't want a pole shooting all the way across the hand. It's more like I want the finger to have structure and whatnot. So anyway, we've now said, hey, there's some structure inside of this thing. So excellent. But we still are saying to mix the animation, where these pinned points in the back have to move there. So let's see what the combination of those two things does. So if I hit play, you can now see that hand, look at the way that moved. The back of the hand slams down, but the fingers are actually kind of drifting. And look at this overlapping smooth animation from the hand moving upward. I know there's a lot of people who do like floating hand animations and whatnot. So you just like, there's no rigging here. Like the hand is just doing some really nice movements. And I'm being very brutal here. The keyframes were terrible. Like just straight down, straight up, straight over. And this is just like full power. There's no subtlety here whatsoever. But yeah, you can see that that's actually working quite nicely. We could change a bunch of settings all over the place. But this is very heavily using pins. Now, instead of pins, we could do something like use force. Now, it's a subtle difference between these. One is saying, hey, this point has to go where the other one said. Where what force is doing is essentially blowing a wind on each individual point and saying, hey, point, hey, Softbody, wherever you are right now, I'm blowing this particular point to go try and match where the original model has now animated to. So it's trying to animate via wind into a particular position. Now keep in mind, we still have that structure from the poles, and the wind is only set to 1 right now, but let's see what we get. So we see it falls, it's going to collide with the ground, but it did stop. And now the wind, this wind is pulling up. Actually, it's applying everywhere. I haven't put a map on there. So every single point is getting a wind applied. But with that in mind, look, now instead of passing through the ground, the hand is actually stopped there. And it's actually making look at this lovely contact that we're getting where the hand's actually pushing against the table, but maintaining some structure. And then it gets pulled up. Now, right now, every single point is being affected. So let's say don't have every point affected. Let's, again, limit it to the pin area. So now only this backside is. So now you can see that pulls down a little bit more. The hand is moving up, still making nice contact. And I think the force isn't quite strong enough to lift that up in the air. So let's add this up to maybe like 5. And now you can see suddenly that gets yanked. So again, only the back part of the hand is getting any effect. And now you can see that gets pulled up. And look at the secondary motion on the hand getting drifted to one side, drifted to the other. So very exciting to blend these animations. So then we can, you can push this further. We could paint different spots to have different structure. Something I was doing, I guess we can bring in the T-Rex for this part. But before we move away from the scene file, just to push it all the way, I've also got this piece of cloth here. And if we make, I'll turn off the subdivision surface. If this cloth is sticky, and you can see right now it's just a little bit sticky, we can say, okay, hand, you will be sticky as well now. So we can start with a number 5. 5 tends to be a good number, just you will see an effect. So if I hit play here, let's look at the cloth and how it interacts with it. So you can see it's colliding with it, and as it lifts away, you see, oh, that's stuck on the hand a little bit, and it's stuck right there just a little bit. So not strong enough. When you don't know a good number, typically it's a good idea to like go up like 100% or an order of magnitude. So I'll go up to 55 this time. So this is way stickier than it had been. So now we collide, and now it looks like that's sticking to the thumb pretty well. And now as it pulls up, look, the cloth is starting to stick to the hand, but only the back of the thumb a little bit. So why don't we say, I don't want everything to be sticky. I'm going to turn off these poles for a second. Let's say don't show them. They're still on, but I'm not showing them. So let's say the surface, I want it to be sticky, but not everywhere. So I've got this other vertex map. I already painted these fingertips. So now only those fingertips will be sticky if I drag that vertex map in. So there's our sticky map. So not changing any settings. Let's hit play and see what sticks. It shouldn't stick to the back of the thumb anymore, but you see over here, that's stuck a bit. And now as it pulls up, the fingertips have a bit of stickiness there, but the cloth still falls away. So again, if it's not strong enough, let's go 10 times stronger again. Let's see what that does. So the hand connects. You can see the fingers are connected pretty well. This one finger is not touching all the way. It'd be better to animate that a little more. But look, now that's sticking on there pretty dang well. So yeah, that's sticking to the fingers. So many possibilities here. You see it slowly drifting away. We could crank the strength up even more. If I revert this to my original file, I've got both hands set up, and I've got tearing turned on the cloth. So now these hands will go down. They're colliding, perfectly taking on the form of like this tabletop. The fingertips are sticky, pulling up the cloth. And then as the hands animate away from each other, it's so sticky that it overcomes the tearing threshold, and the piece of cloth is going to tear in half. So all of that using the new settings inside of our lovely, lovely simulation tag. So very exciting. There's so many things that we're going to be able to do with this. I mean, it's too bad we're on a break right now for Rocket Lasso Live, because we'll be answering so many questions when it comes to this type of thing. There's a couple other technical things that we could talk about that have some ramifications. In fact, why don't I'm going to open up that original head, not sticky, length. So let's open this file up again. So here's that head. Here's a sphere around it. And again, let's add in the simulation cloth. And what did I want to show here? Well, actually, I'm going to make it not the sphere. Let's do a box this time, a cube, and I'll subdivide 12 by 12 by 12. We probably go a little bit higher. Let's start there. So adding a simulation cloth onto there. If we hit play right now, nothing's gonna happen. I have gravity turned off. So we can do things like, I want to show you this. I'm going to keyframe the original model. So I'll delete that simulation tag for a moment. Currently it's a size of 200 by 200 by 200. I'm going to keyframe that. And let's go all the way over to frame 90 and say at this time, it'll have shrunk down to 75, 75, 75. So pretty small. And we'll keyframe that as well. And I'll just position this a little more centered on the head. Now, if I rewind, add that simulation tag back on there and hit play, nothing happens. You see the cube, you can see right there that the original cube is shrinking, but the soft body's like, well, I don't care about it. I care about what I look like at the very beginning. But we can say, actually, with mixed animation, you do care about the things that are changing. So even just with that simple scaling animation, I can say use pins. If I hit play, like I said, complete override. This is now forced to shrink down. It's going to pass right through this head. It doesn't care. But if we put a lower influence, I think it'll care a little bit. So if I play, you can see actually these points are trying to move in, but they can't. And I could give it a little more strength. But so yeah, you see here that it is attempting to maintain the overall length of the object, but the points, the pins, are in a springy type way, like a spring is pulling each point trying to get to the new position. But the box isn't physically stronger. It's just a points trying to get to a new position. So you can see it's just kind of crumpling in. Like the entire thing's like, oh, I'm trying to get to a smaller spot, but I'm still really big polygons. So you can see that that's what the pins are doing. Now we can do a very similar thing here with a force. We can say with force, now individual bits of wind are blowing each of those points in. The strength isn't too high, so I don't think we'll see too much. You can see it's just kind of, bowing in a little bit. But if we make that stronger, a very similar thing is going to happen where all these different pieces are attempting to move into position. And I think the wind is going to work really well for like kind of making that look like it's collapsing. Keep in mind, all other settings matter here. So if this is extra bendy, these can bend more. And if we add a little bit of stretch, they're going to be able to collapse and, kind of twist a little bit more. So all those factors are, actually counting. So that's what the mix animations are doing. But here is something interesting where we've also got follow shape. And what follow shape is doing is it's not saying at the very beginning, let me rephrase this, at the beginning with these other modes, if nothing's turned on or with these two modes, it's like at the beginning, here's what I look like. As a piece of cloth, this is my shape. So, and it will stay that way. But if we say follow shape, then it's constantly updating every single frame. It's going to update and say, oh, I look like that new shape. So if I hit play here, then you're going to see that the actual model is going to shrink down. And now we kind of get it shrink wrapping around the model because it's as if the shape itself is updating. So it's a very powerful tool to also use. And you can use these in conjunction with each other. So this could shrink and also be having wind blowing to try and maintain the position. You can see there it doesn't like bulge outward as much. If I play here, it gets left a little bit behind and that will shrink down. So yeah, very fun combinations on all of those things. I mentioned this in my original video, but something that's kind of fascinating and you should keep in mind because it tripped me up in the beginning is I'm going to kill off those keyframes. So it's not going to scale down anymore. And what I'd like to do is animate our length. So on the surface, oops, not you, and I did it again, on the target length, it'll be 100 at the beginning, and over the course of 100 frames, we'll shrink down pretty far. So again, we'll see a nice kind of simple shrink wrap here. It's very bendy. It's a little bit stretchy. So you can see it's going to do a nice shrink wrap around the head. But we can go and turn on the balloon. And what does balloon do? Well, it's calculating the internal volume of this right now. Like, oh, how much space is there inside? And it's going to try and maintain that. But now we're saying, but shrink these connections. But now the balloon is also saying, but I have a certain amount of air I have to keep inside. So if I hit play here, we're going to see that this is essentially like, okay, I'm trying to shrink, but I'm not allowed to. Like, there's too much air. I can't shrink. So it's kind of a fun thing to keep in mind. And doing the opposite at the beginning, if it's at 100 and then 100 frames in, let's have it inflate to go larger. We are not changing the volume of air. The volume of air has been the same, but the surface area is going to be increasing. So now if I hit play, it's actually going to kind of be imploding. It's like, oh, I don't have enough air to fill my space. I've gotten physically bigger, but it hasn't filled up with more air. So you get a different effect there as well. So yeah, keep these kind of things in mind. To throw it out there, keep in mind that essentially the pressure is cubed, but the length is linear, like two-dimensional. So this has to go up to a way larger number. You would think that if we're doubling the size, we'd only have to double the pressure. But double the pressure, you see, will not be enough air to fill it up. It's going to be more like 5 or 6 because it's like the cubed value of it increasing. So the number is not super intuitive, but just keep in mind the actual model is scaling, not the air filling it, which actually does add some power there. You just have to keep it in mind. Let me see if I had any other files that I didn't open. Because I got the other ones I did in my official thing, but I did have a lot of files when I was just playing around, seeing what I wanted to do. I had the sticky roller demo. That I did show that off. The sticky drift. Oh, here's one I didn't have time to show. So here is a hand, and it is a soft body, and it's got a bunch of poles to give it structure. You can see here. And it is using force to follow around that same vertex map. So this right here. And then I've got a vibrate tag. So essentially the hand, let me just show you. If I turn it on, the hand is via the vibrate tag just spinning around. And then the poles are making it so that the hand is trying to follow, it's trying to maintain its shape. And then the follow position is saying like, well, at least the base of the hand has to follow. So anyway, you can see that the hand actually will move a little bit and the fingers will move in the wind and drift. But then I made a whole bunch of essentially tiny sheets of paper. They've got a couple of subdivisions each. And I have a very soft attractor just so it's generally pulling in. And both of them are very sticky. So if I hit play here, this hand is drifting through the air. These are like little Post-it notes. And now when the Post-it note hits the hand, it gets stuck to it. It's not the attractor that's doing that. It's actually getting the attractor's making it collide with it. But then once it touches, the stickiness is like, well, I'm stuck here now. And you can see that slowly the hand is kind of getting covered in these Post-it notes. They do stick to each other a bit. I wish I could make them just stick to the hand. I mean, I could make these very weak and the hand very strong stickiness-wise, so that might work. But yeah, just kind of covering a hand with stickiness. But very fun. I mean, just thinking of different use cases and demos and fun animations here. Like there's so many possibilities. So yeah, you see all these sticky things layering up on top of each other. So does anybody have any questions in regards to some simulation stuff? Let's see, HJ. How do you get the stacking materials to actually work? Well, this is a little dangerous. My computer does not like me opening Redshift while I'm streaming, and there's a possibility I just like freeze up my entire machine. And it's definitely to do with my video cards. So I'm not going to hit render, but let's see if I can just create a, do I have to change the mode? Yeah, I do have to change the mode. So I'm going to change my render settings to Redshift and create a new Redshift standard material. If I go inside that material, well, it goes to like, that's a base material. So, you know, doing it in the most basic way possible, I could say, hey, apply that to that sphere. And now that material is applied. So now we make a new material. And in this new material, well, it's definitely, let's see, deselect. How's my refresh going? Yeah, I'm a little worried, but I would like to add in a texture. And this texture will be, let me load in something from a file, and we'll load in from the texture. I've got, let's see, we'll do this one. So here's the Golden Rocket PNG, which everybody gets on Twitch. If you subscribe on Twitch, then you get access to those emotes. So now that is a picture and it's got an alpha. So I'll bring in our splitter. So here's a color splitter. And all I have to do is say, take this, I want that image to be the color. And now I want to split that image up into its different components. And I'll take the alpha and put the alpha into opacity. So that's all you got to do. That's now set up to be a decal or the ability to overlay a material. So it's not, like I said, Redshift is not going to cooperate while live streaming. So this icon is not refreshing. I'm going to do a risky thing and tell it to render. Okay, it did refresh. So now if I apply that here and say I would like a flat projection, turn on the texture tool, and now we use all the regular cinema texture tools, I should be able to move that over here. And it's not going to show up in the viewport very well. And I should probably turn off tiling. But now that would be getting projected. And it's probably a terrible idea, but I will open up Redshift Render View. And let's see if we can quickly get something to show up. It's possible nothing comes up, and if it's not cooperating, I'm going to very quickly close it. There we go. Look, instant decal. So as simple as that, in Redshift, we can now stack materials on top of each other. And I think it's often referred to as decals. And I guess that's a type of way people use it, for like putting graffiti or a sign or a particular thing. But I use this type of thing all the time for things like in regular vanilla cinema. I do this type of thing all the time to like transition from like grass texture to dirt texture, or put grime in a particular spot, or use a vertex map to say, hey, there should be rough areas here and clean areas here. And being able to do that with different materials is a nice way of blending between them. So instead of needing to do all of that complexity inside of a single material or blend materials internally, we can now just treat a Redshift material the same way we treated classic cinema 4D materials, just by linking to that opacity. So yeah, a very cool update there. On top of all of these other features, there's a couple. Well, Redshift got a bunch of features over the last few months, and this was one that just came out today. You're back, but dropped. Okay, interesting. Okay, well, that just goes to show why I don't do Redshift. Hopefully you saw the little render pull up and how the decal actually did work on top of there. Let me know if it didn't. But yeah, that's not even going to be a spotty connection. That's going to be my video cards while live streaming. So, I'm overdue for an update, so I'll be doing that. FYI, all of these scene files I did in the video, I put available on Patreon. So if you're supporting Patreon at the engineer level, you get access to all the files that I used in my demo. Let's see, I did the sticky roller animation. You know what, let's just try and do something completely new. We got a little bit of time left, but if anybody has any questions, especially about the simulation stuff, we still got Fritz in the chat who can answer any technical questions I might have if we bump into them. But let's just try and make something new. And like I said, I kind of had that thing stuck in my head where I wanted to see if I could make a hand kind of grab a cheek and kind of move around. So let's steal this hand, open a new file, and I'm just stealing the model. We'll do all of this from scratch. So I've got a hand model, and no keyframes, please. Okay, hand model, and you know what? Let's steal the head from this file. That is not the file. This is the file. So here's a face. Now the hand is huge. I think the face is about the size of a cube, which I'm going to leave it kind of at that default. So everything's a little overscaled right now. But now, so here's the plan. Let's say this person is rubbing their cheek, and let's just see what happens. So that seems about scaled, right? Maybe it's a little large, I don't know. So here's the plan. I'm going to keyframe this hand very roughly, very rough animations here, where that is what it looks like at the beginning. And we'll move 45 frames in, and I'm just gonna have it like overshoot. I'm gonna have it pass through the face. I'll have it rotate a bit as well, just trying to match the angle of the face a bit. The thumb's gonna be fighting the face a little bit, but I'm gonna pull that up. And let's see, I do want it colliding. Actually, maybe the rotation's better that way. So I'm gonna do that. Keyframe, and then hit play for a moment. I'll say, yes, stick around that spot, and it'll go forward a little bit. And here, I'll have it move down. Keyframe again. And a few frames forward. And we'll give it a little more. And then I'll go up a little bit extra. Keyframe. And then a few extra frames, please. A few extra frames here, and we'll have it pull forward. Keyframe, and pull over here. And we'll go a little bit diagonal. In fact, why don't we even like rotate the hand a bit? I have no idea what's going to happen here, so maybe we'll break things. And then a couple extra frames. We'll have the hand like pull away, which could be kind of crazy looking. Even I'll rotate it over, go extra far away. Okay, cool. So we're gonna have terrible rough animation here. Let's hit play. And you see the hand's just gonna pass in, move down, move up, move over, move down. That's all a little quick. I want that to be slower. Let the simulation have time to drift. So I'll stretch those out. And we'll move that, oops, grab this final keyframe, pretty much move it to the end. So let's see how the timing looks on that. Hit play, hand passes through, down, up, forward, back, and then back out again. So, very rough animation, but I just want to see what we can do. So, because it's sort of a dangerous setup, we'll save the scene file. And hand, face. Good enough for me. Okay, so several things need to happen. First of all, this entire head will become a cloth simulation because we do want that to be the case. And we need a vertex map. So let's even keep this loose. Let's add a vertex map. And that vertex map, even though it's not, this has been made editable, we can still use fields. So I'll create a spherical field and scoot this over. I'll turn on snapping so I can snap to snapping. Doesn't seem to want to snap. Whatever. Maybe I didn't turn it on. So I'm going to move that to the cheek area, and we're just kind of say that, like, okay, that area is allowed to bend. Well, I mean, that's going to be an area that we can have do things. So that vertex map will now be called cheek. And that's fine. I'm going to make another vertex map, and this one will delete that spherical field, and I'll make another one. And this second spherical field, let's call this one neck. And that spherical field will go down here. Oh, now it's snapping. Go figure. This one will go down here, and that'll be a way that we can control it via the neck if we want to. So let's just keep that in mind. And now, on the hand, very similar thing. I'll just steal a vertex map, and we'll just call this hand base. And I'll just paint this one. You can double click on a vertex map, and you can just paint. If you didn't know that, it's very handy. So again, I'm just going to make the back of this hand be the stiff part, and everything else is, kind of free to do whatever. So, yeah, that's hand base. Save again, right click, simulation, cloth. Several things we need to do. If we hit play right now, CPU wise, gravity's turned on as well. I'm going to turn gravity off. It's probably fine to have gravity on. I don't know. So if we hit play right now, this is a soft body, that's a soft body, they're just going to fall. So if I play, they should just probably both fall away. Although that head's kind of exploding outward. That's a bit of a surprise. Oh, that's because the head is right now a collider and a soft body, so it's colliding with itself and exploding, which makes perfect sense. Okay, if I play, they both fall away. Exactly what we expected. So to start out with, I'm going to say that this head will be pinned. 100% I'm going to pin, and let's start out with the neck. I'm going to say the neck is stuck there, but everything else can do whatever it wants. So let's just hit play and see what happens there. And now you can see that actually, if it did work, this neck is stopping the head from moving at all. Let's double check. If I turn it off, it falls. If I turn it on, just based on this neck, the entire thing is staying there. So excellent. And now the hand, we need to essentially do the same thing. I might do it immediately with force, so there's like a wind blowing the hand. It's a little softer, I think. So let's say that the base of the hand is going to have a wind blowing on it. And let's give it a decently strong force, like 7. I'll hide these spherical fields. So there's no stickiness or anything, but right now this entire head should be being soft body. It's all simulated except for the neck. And now the whole hand is simulated except for the base of the hand. So let's just see what happens. Hit play. Hand now moves forward, and you can see it's striking the face, squishing all over the place. It's acting like it's a rubber glove, and then getting pulled away. The thumb did pass through a little bit more than I'd want to see happen, but we'll just have to experiment a little bit. Okay, so what do we need to do? Well, first of all, I feel like the head is very low poly, but it wasn't very bendy or anything. So let's add in a little bit of stretchiness and a bunch of bendiness, and hit play. And the head is very static. Why is the head not? The head is acting as if it's just a collider. I wonder if it's kind of is the head confused because I had the collider on it? There is a thing where the simulation can sometimes forget or it can remember a setting. So if I set this to GPU and hit play, that's going to kind of force a refresh and go back to CPU and hit play. And see, it's still not reacting at all. I really want to see it react. So I'm going to click on the hand and tell the hand that has a lot of mass. So it's like very heavy. And the head is still not reacting, which is interesting. I'm going to delete that tag entirely. And let's just add a new cloth tag on there. Mix animation. I like eliminating variables. So we'll add that neck on and hit play. And I'm starting to think that the entire head is pinned. Maybe this neck map isn't passing through very well, but I don't know. So let's temporarily turn off fields. I'm trying to eliminate variables. And I turned off fields, but it's still remembering that. So let's see if that did a difference. So hit play. It's still not reacting. What might I be doing wrong here? Very strange. Let me think. Think-a-do. Isn't that the opposite? Well, yeah, yellow equals simulation. But that's opposite of the hand, right? Oh, I didn't set the hand up yet, did I? Oh, I painted this. Did I undo? Why is that not there? Well, anyway, Fritz is saying I'm doing it backwards, which he's totally right. Oh, I didn't even think about it. The back of the hand had been red. Okay, this was all my fault. I need to invert the output of this tag, which is not... that's using a field right now. Okay, there we go. That is now correct. And now if we go up to the head and invert, that should be correct. That's now the static part. I completely went backwards on that. What's funny is I did it correct on the cheek, and then I forgot to invert it for the rest of it. So anyway, that was on me. Now that head, let's go back to this having a regular amount of mass. So that should now be able to be simulated again. And now you can see that the head is falling down, which is kind of what was expected. So now let's tell the head that it's not going to be very bendy. So it's going to, you know, the whole head is falling down a bit. So we do have some options where on the head, I mean, first of all, we could turn off gravity, and that might be a smart way of going. But we could try adding some structure to the head by adding poles. We could add a bit of mix animation kind of everywhere, like just a little bit of wind on every single point, trying to tell it to go to its original position. So after I play, you see, just by turning that on, the head is working just fine. And now the entire hand has flopped over because now the simulation is actually working correctly. So on the hand, we need to add structure. So let's go to Softbody and say, yes, let's add a couple of pins. Let's add a bunch of variation, limit the length, and there we go. That has added structure, and I want this to not be squishy. So structure on the hand, hit play, and it's still falling over a bit, but you can see a lot more structure in the hand. So a couple things we can do. Let's paint that to go a little bit further. And, I mean, that's still not going to be enough. I imagine the hand will still fall over. Let's find out. Yeah, you see the back of the hand is trying, but now we can say, okay, hand, that's fine. You can get more wind for one, so the back of the hand really could. Okay, slow down, slow down. So now we're saying there's a lot of wind on the back of the hand trying to keep it up. I think it's falling and exploding, so that might be too much wind everywhere. And then we've also got this map scale, which I think could mean that some force is still being applied everywhere. Yeah, so I think a bit of force is being applied everywhere now. So a little bit of that could go a long way. You can hit save again. Hit play. Okay, good. Structure is good. Pushing against the face. Nice. Oh, that exploded. Okay, I'm not sure what to do about the exploding. We have a lot of forces here. This is really strong now. Like I said, this is a dangerous experiment, so less force. That's very gingerly touching the face. But like, I like these contact points. That's pretty good. I'm going to tell the face isn't very bendy right now, so I'm going to add a little bendy, a little stretch. And let's see. So that very gently touching right there. And yeah, you can't see it's kind of squishing, it's squishing it around. Right now there's a lot of friction. I'm going to turn off the friction on both of them. So we'll say no friction between either of them. The thickness does matter. There's a lot of weird details here on the fingernails where those polygons get really tight. And then, but there's other things. Like right now, the collision side is on the front and the back. I'm going to say try and collide only with the front. So we'll see if that, let's just see what the behavior is. That seems fine. It's more smoothly moving around the face, that's for sure. I think I need to tilt the whole thing forward. But anyway, like that's kind of working. I wouldn't mind a little more structure in the hand. So maybe a couple more pins would be a good idea. So body, let's stretch the pins out so they can have more structure further away. And we'll say up to 3 pins per. And we even do a little more variation on the angle. So the hand should have even more structure. And now, it shouldn't tilt so quickly. I'm going to temporarily take the tag off of it. And go to this first keyframe. I guess it didn't tilt too much. But I'm going to tilt that into the face a little bit more. Being quite cruel to it. But... and yeah, that one can then move back out again. So I just want to see that as the initial thing. And I'll move the tag back on. So we get the hand. I guess the fingers kind of fall down before they move up. So that's what's doing that. Well, anyway, I mean, there's going to be some nuances here. What if we make the hands bendier? 55. So the fingers could be more bendy, but the pole, let's make the poles a little bit bendy. I haven't done too much of that. So the poles are like, okay, I could bend a bit. Well, then they're squishing too much. See, that's why I don't bend the poles, because then like the whole hand is squishing, which could be handy depending on what you're doing. But in this structure, in this, I just want some structure. So that's a large area. Well, the entire head is actually soft body right now, not just the cheek. But I'm just going to go ahead and add some friction or some stickiness here, and let's start seeing what happens. So here's 5 sticky. Let's turn off those. So, squish, squish, and look, the finger got stuck on the face there. So okay, that's fun. Let's add I'll add a soft body or a subdivision surface on there just to smooth that out a bit. So let's grab both of those tags and make it 10 times as sticky. So way stickier. So the entire hand is sticky now, and now you can see it's getting very sucked to the face. And now as the hand moves, like it's just squishing the whole thing. And then the hand's trying to pull away and it gets left behind a bit. So, okay, that's fun. Now, things do go to, like the hand will self-stick. I kind of wish there was a way of, a request I might have would be that stickiness doesn't affect the object it's on directly, because then this hand could ignore itself but stick to other things. For now, a way around this would be saying that this hand is only a little bit sticky. And then we can make the face very sticky. So now the head, now the hand is not very sticky, but the face is very sticky. So the hand really shouldn't stick to itself too much, but it's going to want to stick a lot onto the face. So yeah, like it's trying to force a smile on there and then pull it all back. Yeah, a lot of different settings to play around here. Like even here, I'm using pins, but we could use a force on the base of the hand. And now that's going to force into a particular position. And already you can see very different movement there. And then actually we could do both. Let's add a little bit of force everywhere. Just a bit. So it's trying to get to that original position. And the pin is only on the base. And that squishes around. The structure seems to be a little bit better on the hand, but still collapsing a bit. We could say that the hand doesn't want to bend at all. Let's put 0 bendiness on the hand. Squish. Oh, there we go. That worked pretty well. Like, no, getting rid of the bendiness in the hand went like a really long way. I think the fingers were too free to bend, and now they're trying to maintain their shape a little bit more. So the hand's already a little bit curled, and that's what's causing the problem, where everything's like very everything is colliding too quickly instead of kind of cupping the cheek. It's kind of like ramming the fingers into the side. But the concept is totally there. It's totally working. We just have to spend some time like making a better hand shape. And if this was a rigged hand, we could actually form the finger shapes and get it to match a little bit better. I'm being very cruel with the amount I'm just like crashing this straight through. So I'm actually quite pleased with how that's starting to work and how this is like squishing that face around. Let's make this very stretchy, very bendy. So this should, you know, kind of go wherever the hand tells it to go. So squish, squish, squish. Really like stretchy face pulling away. Now, yeah, these pieces are kind of colliding with itself on the head a bit. For the mix, we're using pins. Pins could possibly cause that. Maybe it would be good just to do a little bit of force on the overall head. So yeah, the head is just kind of gently saying, oh, I just kind of gently want to be in this position in general. Nothing's getting pinned. They're still passing through each other a little bit. But it does go to the faces. You know why that's happening is the face is very sticky. So if one part of the face touches another part, the face is like, well, I'm stuck. So to keep, well, something we could do is say, okay, the face is going to only be sticky in the cheek. So now the rest of it won't stick, but only the cheek will be. And keep in mind that's in this area. So those are the only parts that are actually sticky. You can see how those fingers are like maintaining a connection to that spot. And then stretch away. Oh, poor face. Pretty fun. Okay, any questions or crazy stuff to that we should try here? We've got just a little bit of time left. Oh yeah, like manually sculpting a duck face via a hand crashing through. Yeah, the sticky. Yeah, Fritz was just pointing out that I had the stickiness up so high in the face that it's like self-colliding. But yeah, all the forces kind of fight each other. So I have a tendency to try and put like very strong numbers in here. But like a stickiness up that high is potentially dangerous where it's going to override a lot of the other like connections and springs and forces. So a lighter touch could go a long way. Probably would be better to like leave the face not being overly sticky and the hands not being too sticky. But then saying like only the fingertips are sticky on the fingers. But yeah, actually the hand movement's better there. If you ignore the face because it's super squishy right now, like look at the way this hand is moving. If you just look at the hand, considering there's no rigging on these fingers, like for how terrible it was what I threw in there, like look how nice the hand is working. Like very pleased with that. Loop. Excellent. Mateo wants to just slap the face. I think we could do that. So let's delete all of our keyframes. Just do a nice simple hand right there. Nice slap across the cheek. The hand's going to lag behind, so let's just move this over and keyframe the position and have it go relatively quickly. And just travel straight through. Keyframe that. Okay, we'll leave all the same settings, so the back of the hand should still be what's driving it. And this face is just kind of gently floating in that position. And let's get rid of all the stickiness. We don't need any stickiness. But maybe we want a bit of friction, just so like the face might be pulled along with that. And the face right now is very bendy. I'm going to put that to a minimum, and we'll put the stretchiness to a minimum as well. So just a test out of the gate. So now, okay, the hand properly going. Okay, that worked pretty well for our first try. Let's tilt this hand upward a bit. And maybe something a little bit like that. So get that to travel. Boom! That is pretty dang good for like just throwing it at it. Like first try, not knowing what we were going to get. Boom. So if we made different parts of the face stiffer, like you could probably add some structure where the cheek could be very squishy and other parts could be less squishy. And we've also got the global simulation drag here. So it's draining some of the energy out. So if we get rid of that, there might be a little bit more overlap. And what are things? I mean, I guess more, let's just, I'm going to add a bunch of stretchy, a bunch of bendy. Let's see what that does. Boom. And then keep in mind let's turn off gravity. Because right now the head is receiving a bunch of the mix animation, which is kind of keeping it in place. So if we turn that off, the face should be kind of free to just simulate. So now it's gonna the whole thing is gonna freaking fly away. So maybe that's not a great idea. Let's pin the neck again. I think that might be working. Yeah, the neck is pinned. Now it's very stretchy, and the friction is holding it there. So that's gotten a little bit cruel there. What would be the best setting there? I mean, it's very, very bendy. So let's get rid of some of the bendy, some of the stretch. It's still probably going to drag like really far over there. Bloop. Oh, yeah. I mean, now it feels like it's hitting a rubber mask instead of something with structure. Not surprising. So again, putting a little bit of overall force here, so the overall face is like, I want to be in a particular spot. Actually, that didn't seem to be the key variable there. Let's try adding a few pins. Probably not going to be the biggest thing because those are going to connect through the entire head, but might add a bit of structure. Oh, that's pretty good. I mean, if the neck is bending a lot, but like the overall structure of the head's working pretty well. Boom. Like the cheek is reacting in a pretty big way. So yeah, these poles go a really long way. Let's add on 2 more layers of them. Just add some more structure. Poof. That's not bad. That is not bad at all. So yeah, the mixing of animations now, like, man, have we added in a lot of possibilities. Low pins everywhere and soft body. Change the color. Oh, it's clay colored right now. It's neutral, but we'll make it gray. How much money did they spend in the third Matrix movie to get this to work? And now we've got this going here. Boom. Yeah, if we change the vertex maps a little bit, like where the neck one is, we could try adding a little more fall off. It is, oh wait, I turned off it being procedural. Let's make it procedural again. Turn off that freeze. Scale this up and a smaller inner circle, please. And a bit of fall off all the way through. And yeah, that is not simulated. And that is now where the neck is stuck. So there's a little bit more of a fade up. So that, yeah, you see it? Okay, yeah, so it's way more sticky. That's actually pretty good for just kind of whipping it in there. The neck has a little bit more of a fall off. So the entire face is sticking a little bit more. And not to put too fine a point on it, but if we made a second version of the head, so if I were to make this head again, and I hit D for extrude and just shrink the entire thing in a little bit, if we kind of just shrink the whole face in and make that, I guess what I'd probably do is make it another cloth, and this cloth would have like no friction, no bend, and then it could have a bunch of pins with 0 structure. Probably a different seed. Essentially, it's like maybe I put a skull in there. So there might be a skull floating around inside of it to give it additional structure. It would be even better if it was rigid body, but we don't have that yet. Oh, and it's soft body right now. I could make a collider, but then it couldn't move at all. I guess as an experiment, that could be fun. So I'll just say simulation collider with 0 friction. So now there essentially is a static skull that can't move. So now this is just getting, yeah, you see this is getting stretched along in front of the skull. So like this can only move so far because it's colliding with the interior skull. So if we pinned the nose or made that more stiff, anyway, you can see how we can start layering up additional things all over the place. It gets super crazy. So anyway, somebody requested a slap and it's working surprisingly well. I guess we'll save that file. E2A face slap. Okay. I guess I have time not to answer a question, but just to audibly answer a question or two. Yeah, you could turn tearing on. Motion Punk is asking when the utility spines are coming out. I was hoping to get them out here, and I couldn't talk about it. But the last month, I really wanted to get the tool out, our upcoming utility spines. I recorded a bunch of the videos, but then because of half-res is in 2 days, and I had to get the new video out of the new features, that interrupted it. So I'm hoping in the next month. That's my plan. We'll have to see. I I guess I should throw out there that if you are in the Chicagoland area, I mean, first of all, is anybody in the chat on YouTube or Twitch coming to HalfRes? HalfRes is a conference we run in Chicago. This will be the official 9th one. So it's an event that I co-started. It came from Chicago C4D, and then Grayscale Gorilla was involved, and now I run it with a committee of people, and we're going to have speakers. There's a whole bunch of great speakers that are going to be arriving. If you haven't checked it out, you should head on over to halfres.com, but you're going to have to be like close by Chicago because nobody's going to come out for a one-night conference and travel really far with 2 days short notice. But if you are coming, I'll see you there. And if not, you should think about coming next year. It always happens, HalfRes always happens right around mid-September. So it should be exciting. We're going to try and record some of it, but who knows if and when that stuff will get posted. But anyway, a lot of fun stuff here. We're going to be doing so many crazy things when it comes to this simulation stuff in future live streams. Unlimited tutorials just from what we've already got, and they're still going strong as far as adding features. So I am excited for the future. The sticky stuff, the soft body poles on there, and then the mixing of the animation. Like it's something I've been saying, but a simulation system is just a fun simulation system. But once it has the ability to follow keyframes around, now it's become a motion graphics tool. So now we've got 3 different ways of mixing in animation. So that is opening up a lot of cool possibilities. Yes, also IBC is happening at a very similar time. I'm also going to be at Camp MoGraph a week after HalfRes, so that could be exciting. Eric, when is Rocket Lasso Live starting up again? Well, it only stopped 2 weeks ago. I'm hoping to start in January. Probably, I'll try and start early January, like right after New Year. That'd be a good idea for it to happen. There'll be other things happening on behind the scenes, so we'll have to just see how it all shakes out, but that's kind of the plan right now. That's going to wrap this up, everybody. Check out the full main video. I'll put a link to that because I think I saved. Nope, that's not it. Here it is. Give me the URL. Nope, give me the proper URL. Come on. Copy. Okay, here's the URL to the full video. Check that out to see a breakdown of all the features, although we did cover a lot of them here. The video will have more detail. If you want to support Rocket Lasso, the best way to do it is to pick up one of our plugins. Pick up a plugin. Now you get new superpowers inside of Cinema with our spline tools and recall, and it'll help hopefully make you more money, and you support Rocket Lasso. If not that, then we've got Patreon, where you can get access to scene files and access to videos early. Most of the time, I can't exactly release what's new video early on Patreon, but you get access to videos early and scene files. I just uploaded all my scene files from the new video onto there. And you also get like a bunch of free models and discount codes for all the plugins as well. And like I mentioned, if you have a Amazon Prime subscription, you can for free subscribe to Rocket Lasso on Twitch, and it doesn't cost you anything, and it helps us over here a little bit, so that's always appreciated. But anyway, that is going to wrap this all up. Make sure you are following on Twitch. You get an update when I go live again. There's also the Rocket Lasso newsletter. Head over to the site for that. I'll see everybody on the Rocket Lasso Slack channel, of course, as always. But for now, I think the bonus live stream after the end of the season has concluded. So thank you so much, everybody, for hanging out. This was fun. I'll see everybody at HalfRes or at some show somewhere or in the next live stream or tutorial. Bye-bye, everybody.